Welcome to A-Level Chemistry. Today we are going to go through the October-November 2021 paper 12, which is the second variant for the multiple choice paper for this session. And as we go through the questions, I'll give you some tricks that you can use during the exams to get a good score. Now, one of the most important tricks is always to read the questions carefully, because one of the mistakes I made while practicing for my exams was that I read the questions in a hurry and I always ended up missing some important details and I made lots of silly mistakes as a result. So, to get a good score, read the questions properly, carefully, and you'll be able to answer all the questions. So, we'll start from question 1. Compound X consists of 40% carbon, 6.7% hydrogen, 53.3% oxygen by mass. What is the empirical formula of compound X? Right. So before we delve into calculating the empirical formula, always make sure that you sum up the percentages and make sure that they add up to 100, because if they don't, that means they've left out some element which they want you to figure out. And in most cases, that element would be hydrogen. They've given hydrogen in this case, but for example, if they only gave you 40% carbon and 53.3% oxygen, they would want you to figure out how much percent hydrogen is there. So a good practice is always to make sure that the percentages add up to 100. So to calculate the empirical formula, we'll draw a table. And we'll assume that there are 100 grams of compound X. So that will make our calculations easier. So for carbon, the number of moles is equal to 40 over 12, which is equal to 3.33. For hydrogen, the number of moles is equal to 6.7 over 1, which is equal to 6.7. And for oxygen, it's equal to 53.3 over 16, which is equal to 3.33. So we have these moles, and now we'll calculate the ratios, and we always use the lowest number. We divide everything by the lowest number of moles, which is 3.33 in this case, to get the ratios. So this becomes 1, 2, and 1, which means the empirical formula is CH2O, and that's option A. Question 2. Which statement is correct? 1 gram of hydrogen gas contains 3 into 10 power 23 moles of 3 into 10 power 23 atoms. Let's see. So hydrogen gas has a mass of 2 grams per mole. So 1 gram would be half moles, because 1 over 2. And you know that for every 1 mole, there are 6 into 10 power 23 atoms or molecules. That's Avogadro's number. But remember, even though 3 into 10 to the power 23 is the correct number, because we only have half a mole, it's hydrogen gas. And therefore, it should be atoms and not, it should be 3 into 10 to the power 23 molecules, and not atoms. So it would be Avogadro's number of atoms, because each molecule has 2 atoms. So 3 into 10 to the power 23 molecules, and therefore 6 into 10 to the power 23 atoms. So this is wrong. 4 grams of helium gas contains 1.2 into 10 to the power 24 atoms. So the mass of helium is 4 grams per mole. So the N in this case is equal to 4 over 4, which is equal to 1. So 1 mole of helium gas should only have 6 into 10 to the power 23 mole, 6 into 10 to the power 23 atoms, not 1.2 into 10 to the power 24 atoms. This is double, and therefore this is wrong. Option C, 16 grams of methane gas contains 3 into 10 to the power 24 atoms. So the mass of methane is 12 plus 4, because CH4, which is 16, and therefore N is equal to 1 over 4 over 16 over 16, because we have 16 grams. So 16 over 16, which is equal to 1 mole, which means there are 6 into 10 to the power 23 molecules of methane gas, and each molecule of methane gas has 5 atoms. So this will be 6 into 10 to the power 23 times 5, which is 30 into 10 to the power 23. 10 to the power of 23, and that is equal to 3 into 10 to the power 24, and that's what the option is. So C is correct, but we'll read D to make sure that what we've gotten is right. 44 grams of carbon dioxide gas contains 6 into 10 power 23 atoms. So the mass of MR of carbon dioxide is equal to 12 plus 16 into 2, which is equal to 44, which means which means we have 1 mole of carbon dioxide, because 44 over 44 is equal to 1, which means we have 6 into 10 to power 23 molecules of carbon dioxide, not atoms, because there are 3 atoms in each molecule of carbon dioxide. So this is wrong. So C is the correct answer. Technetium, Tc, is a second transition element that does not occur naturally on Earth. One of its isotopes has 56 neutrons. What is the nucleon number of this isotope? So if you look at the periodic table, the atomic number of technetium is 43, and one of the isotopes has 56 neutrons. So the nucleon number is the sum of protons plus neutrons, and that is 43 plus 56, and that adds up to 99. So this was a simple addition question. Question 4. Which atom has more unpaired electrons than paired electrons in orbitals of principal quantum number 2? So carbon. So for these types of questions, always write out the full electronic configuration. So carbon is 1s2, 2s2, 2p2, and in 2s there are only 2 electrons, both of them are paired. So we look at 2p, 1 and 1. So both of these are unpaired, and the question says which atom has more unpaired electrons than paired electrons in orbitals of principal quantum number 2. So there are 2 paired and 2 unpaired, right? So this cannot be the answer. Nitrogen is 1s2, 2s2, 2p3. 2s again both paired. For 2p it becomes this, and therefore there are 2 paired electrons and there are 3 unpaired electrons, and the question says more unpaired than paired. So nitrogen seems to be the correct answer, but again we look at everything. Oxygen is 1s2, 2s2, 2p4, and again 2s everything is paired. 2p is 1, 2, 3 and 4. So we have 4 paired and 2 unpaired, because these 2 are paired, the 2s electrons are paired, and then these 2 are unpaired. So 4 paired, 2 unpaired, so this cannot be the answer. Fluorine is 1s2, 2s2, 2p5. 2s again both paired, 2p is 1, 2, 3, 4 and 5, and therefore we have 6 paired and only 1 unpaired, and this cannot be the answer because we need more unpaired than paired for this question. So B is the correct answer. Question 5. Atom X is the central atom in a molecule. In this molecule, atom X has 4 pairs of valence electrons in its outer shell. The 4 pairs of valence electrons include at least 1 bond pair and at least 1 lone pair. Okay. What could be a possible shape for this molecule? So it can't be linear because there are 4 pairs of valence electrons, and they say that there is at least 1 bond pair and at least 1 lone pair. So because of the lone pair bond pair repulsion, the molecule will not be linear. Remember, the lone pair repulsion is the highest, and then lone pair bond pair repulsion is also quite significant. So the molecule will not be linear as a result. Non-linear, yeah, that sounds like a plausible answer, but we'll see what the other options have to say. Trigonal bipyramidal, it needs 5, so trigonal bipyramidal actually needs 5 pairs of electrons around the central atom, and the question says there are only 4 pairs of electrons in the valence electrons on the central atom. So trigonal bipyramidal cannot be the case. And trigonal planar, it has 3 bond pairs and 1 lone pair, which means that so the molecule will be like NH3, and therefore trigonal planar. Trigonal planar means that the molecule cannot have a lone pair, because again lone pair bond pair repulsion, because we have at least 1 bond pair and at least 1 lone pair. So if you look at NH3, it has a lone pair and it has 3 bond pairs, and it becomes bent, like it becomes trigonal pyramidal instead of becoming trigonal planar like this, because of the lone pair bond pair repulsion. So for option A and option D, you need to consider the lone pair bond pair repulsion. Option C, there are 5 pairs of electrons, and therefore option B is the only plausible answer. Which molecule has the largest overall dipole? So A, no, this does not, because it's symmetrical. The molecule is symmetrical like this around these axes. And then if you look at B, it does have a significant dipole, but let's see what the other options have to say. C, B has a dipole because delta negative, delta positive here. Now in C, the dipole will be even larger because delta negative on the oxygen, delta negative on the chlorine, delta positive on the carbon. So you have more electrons being pulled away from the carbon because it is attached to 2 electronegative elements, and hence the dipole will be even larger. So C seems plausible. And D is symmetrical about this axis and this axis as well. So D cannot be polar. D will not have an overall dipole. So the answer will be C. Question 7. The strength of hydrogen bonding increases as the electronegativity of the element bonded to hydrogen increases. Some information for a range of hydrides is given. So we have the hydrides in this column and we have the boiling points in this column. Which statement and reason about these hydrides is correct? The boiling point of pH3 is much lower than the boiling point of H2O because pH3 does not form hydrogen bonds or instantaneous induced dipole forces between its molecules. So while the first part of the statement is correct, that it does not form hydrogen bonds, phosphorus is not that polar that it will allow hydrogen bonds to form, there are instantaneous induced dipole forces between the molecules. There are always ID forces will be always present in these molecules. Polar, non-polar, whatever it is, they will always be present. So this cannot be the answer. Option B, the boiling point of HF is higher than the boiling point of HCl because the bond energy of HF is greater than bond energy of HCl. Now intermolecular forces have nothing to do with bond energy. So this cannot be the answer. The boiling point does not depend on the bond energy. It depends on the attraction between the molecules, not within the molecule. Option C, the boiling point of H2O is higher than the boiling point of HF because each hydrogen bond between the water molecules is stronger than each hydrogen bond between HF molecules. This is wrong because the fact that fluorine is more electronegative than oxygen will mean that the hydrogen bonds between HF molecules will be stronger than the hydrogen bond between water molecules. So this option is wrong, and then option D is the only option left. Let's read that out. The boiling points of pH3 and HCl are similar because the molecules of pH3 and HCl have the same number of electrons and similar intermolecular forces. Now this is correct because if you count the total number of electrons, valence electrons in both pH3 and HCl, they'll add up to be the same. In fact, not just valence electrons, also the internal electrons, and therefore, and both of them are phosphorus and chlorine both are polar than hydrogen, so the polarity of the molecule will also remain the same. Both are more electronegative than hydrogen, so the polarity of both molecules will remain the same, and overall, therefore, there will be similar intermolecular forces between the molecules. So option D is the correct answer. Question 8. The general gas equation can be used to calculate the value of Mr of a gas. For a sample of a gas of mass m grams, which expression will give the value of Mr? So we start with the general gas equation, which is PV is equal to nRT. We know that N is equal to M over Mr, and therefore we can write PV is equal to mRT over Mr, and hence Mr is equal to mRT over PV. So that is option A. Just rearranging the equation. The equation for the formation of ammonium chloride is shown. NH3 plus HCl gives NH4Cl, and they've said that it's an exothermic reaction. So let's underline that. Which diagram shows the correctly labeled reaction pathway diagram for the decomposition of ammonium chloride? So decomposition of ammonium chloride is the reverse of this reaction. So we are going this way in the question, and therefore it has to be endothermic. So because the forward direction is exothermic, so the back direction will be endothermic. So we need to look at the reaction pathway, which is endothermic. So that that narrows our options down to A and B, because if you see C and D, these are only for exothermic reactions. So C and D cannot be the correct answers. And then the activation energy, option B will be the correct answer, because activation energy is always from the starting material, the reactants, to the transition state. So it will always be from the reactants to transition state. This is not the activation energy, this is the activation energy. And hence the correct answer will be B. Now let's move on to question 10. In a catalytic converter in the exhaust system of a car, carbon monoxide is oxidized to carbon dioxide and nitrogen monoxide is reduced to nitrogen. What are the changes in oxidation number of carbon and nitrogen in these two processes? So let's look at carbon monoxide and carbon dioxide. So oxygen will have -2 oxidation state and carbon will have +2. Two oxygens will give a total of -4 oxidation state. So the carbon in this will have +4. So the oxidation state of carbon changes from +2 to +4, and therefore it's increased by 2. And the only option that allows this to happen is option D. So we didn't even have to look at nitrogen, but because it's good practice, we'll always look at nitrogen and the other option. So N2, it's not N2O, sorry, N2, it's just N2. So oxygen has a oxidation state of -2 here, so nitrogen will have +2. And then molecular nitrogen, it's an element, so oxidation state of 0. And therefore the oxidation state decreases by 2, because +2 to 0, and therefore -2, which is present in D. So that means we chose the correct option. And then question 11, NO and NO2 are present in the lower atmosphere as pollutants. The reaction sequence shows the production of ozone from oxygen in the lower atmosphere. This sequence repeats many times. So they've given you the reaction sequence. Which statement about this reaction sequence is correct? NO is acting as a catalyst, but NO2 is not acting as a catalyst. So this is wrong, because if you see, there is no net change in NO2 because it's consumed here, but it's produced here. And then same with NO, it is produced here but consumed here. So both NO and NO2 are acting as catalysts, and therefore this statement is wrong. Option B, NO2 is acting as a catalyst, but NO is not acting as a catalyst. Again, that's wrong. We know both are acting as catalysts. Neither NO nor NO2 are acting as catalysts. Again, wrong. So option D, which is both NO and NO2 are acting as catalysts, is correct. A mixture of two period 3 oxides are added to water. A solution forms with a pH of just below 7. What could be the constituents of this mixture? So Al2O3 and MgO. Now Al2O3 does not dissolve, and MgO will dissolve partly in water. So overall the solution will be alkaline. And it says pH is just below 7, which means it has to be slightly acidic, not alkaline. Option B, Na2O and MgO. Now both of these will dissolve to give an alkaline solution, so this is not correct. Na2O and P4O10. This can be correct because Na2O will dissolve to give an alkaline solution, P4O10 will dissolve to give an acidic solution. So overall the pH will be about neutral, which means just around 7. And then SO3 and P4O10 both will dissolve to give acids, so the pH will be very low because SO3 dissolves to give sulfuric acid, which, as you know, has a pH of around 0. So this will give a very acidic solution, not a pH of just below 7. So question 12, the option C is the answer. Question 13, which statement about the compounds of the group 2 metals is correct? Barium carbonate is less thermally stable than strontium carbonate. Now this is wrong because ion polarization is more in strontium, and therefore the thermal stability of strontium carbonate will be lower because strontium has a larger ion. As we go down the group, the size of the ion increases, hence the ion polarization increases, and hence the thermal stability decreases. So strontium will have a lower ion, will have more ion polarization. I made a mistake there. As we go down the group, the size of the ion increases and hence the ion polarization decreases because the charge density decreases. So barium is below strontium in the periodic table, and therefore barium will have less ion polarization, and therefore barium carbonate will be more thermally stable. So this is wrong. Barium sulfate is less soluble than magnesium sulfate. This is correct because the solubility of sulfates decreases down the group, and therefore barium sulfate will be less soluble than magnesium sulfate. And calcium hydroxide is less soluble than magnesium hydroxide. This is wrong because calcium is below magnesium in the periodic table, and the solubility of the hydroxides increases down the group. And then option D, calcium nitrate is more thermally stable than strontium nitrate. Again, strontium is below calcium in the periodic table, so strontium will have a lower charge density, so there will be less ion polarization in strontium nitrate, and therefore the thermal stability will be higher in strontium nitrate, not in calcium nitrate. So this is wrong. Option B is the correct answer. Question 14. A 0.005 mole sample of anhydrous calcium carbonate is completely thermally decomposed to give 100 centimeter cube of gas. So before we delve into anything, let's write down the formula because it's always nice to visualize what's happening. So this is simple, the formula. In a separate experiment carried out under the same conditions, a 0.005 mole sample of anhydrous calcium nitrate is completely thermally decomposed. The volume of gaseous products is measured. So let's write the equation for this reaction. Right. Now, what total volume of gas products is produced from the calcium nitrate? Okay, so they've done this under a certain set of conditions. We don't know the conditions. So we know that a 0.005 mole sample of anhydrous calcium carbonate will give 0.005 moles of carbon dioxide because there is a 1:1 ratio between these two. So what we'll do is we'll calculate the we have a ratio here that 0.005 moles of gas is 100 centimeter cube in volume in under these whatever set of conditions they are using. And in the separate experiment, they have 0.005 sample of anhydrous calcium nitrate, which is thermally decomposed, and the volume of gaseous products is measured. So the total number of moles of gas on the right side is 5 because 4 plus 1, and 2 moles of calcium nitrate give 5 moles of gas, which means that 0.005 moles of so 5 gives 2, and 0.005 will therefore give 2 gives 5, 2 moles gives 5 moles, 2 of calcium nitrate gives 5 of gas, which means 0.005 of calcium nitrate will give 2.5 times 0.005 because the ratio is 2:5. So this is equal to and these many moles, and we know that 0.005 moles is 100 centimeter cube, and therefore it's 2.5 times 100 because 0.005 moles will give 100 centimeter cube gas. So 2.5 times 0.005 will give 2.5 times 100 centimeter cube gas, and that's 250 centimeter cube of gas, and that's D. Question 15. Redox reactions are common in the chemistry of group 17 elements. Which statement is correct? Bromide ions will reduce chlorine, molecular chlorine, but not I2. So this is correct because chlorine will displace bromide ions from their salt solution because chlorine is more reactive than bromine, and therefore this will give Br2 and Cl negative ions as a result. So chlorine has been reduced, but because bromine is more reactive than iodine, bromide ions will not be able to reduce iodine because the iodine will not form I negative and the not molecular bromine. So this option sounds feasible, but we'll read all the others. Chlorine will oxidize bromide ions but not iodide ions. This is wrong because chlorine is reactive than both bromine and iodine, so it will displace both bromide and iodide from their salt solutions. Option C. Fluorine is the weakest oxidizing agent out of F2Cl2Br2 and I2. No, this is wrong. It is the weakest reducing agent, but it is the strongest oxidizing agent because it is more reactive than chlorine, bromine and iodine, and therefore if it's added to a salt solution of chloride, bromide or iodide ions, it will oxidize the halide ions to molecular chlorine, molecular bromine and molecular iodine respectively. Option D, iodide ions are the weakest reducing agents out of F negative, Cl negative, Br negative and I negative. Now the F2 is the weakest reducing agent, as I said, so iodide therefore has to be the strongest reducing agent. It is the weakest oxidizing agent because if you add iodide ions to chlorine, it will reduce the chlorine to chloride ions. If you add the iodide ions to bromine, it will reduce the bromine to bromide ions. If you add it to fluorine, it will reduce it to fluoride ions. So it's the strongest reducing agent, not the weakest reducing agent. So option A is the correct answer. So we move on to question 16. Silver chloride and silver iodide form equilibria when added to water. So they've given the Kc is equal to K1 for this one and K2 for the other one. Each equilibrium position lies well to the left, which is why you see the precipitates. They're these silver halides are essentially insoluble. Silver iodide will not dissolve in aqueous ammonia. Silver chloride will dissolve in aqueous ammonia. Another equilibrium is formed, so they've given you this equilibrium. The position of this equilibrium lies to the right. What is the order of magnitude for these equilibrium constants? So you know that because silver chloride is dissolving in ammonia, K3 is going to be large because the equilibrium lies to the right. The more the equilibrium lies to the right, the larger the value of Kc. So K3 is going to be the largest, and that narrows our options down to C and D. And then we know that silver chloride, we know that silver iodide does not dissolve in ammonia, but silver chloride does dissolve in aqueous ammonia, and therefore the smallest is going to be K2 and K1 is going to be larger than that because silver chloride is still soluble but silver iodide is not soluble, and therefore K1 is greater than K2 and K3 is greater than both of them. So the correct answer is C. Question 17. X is the ion of a metal which burns with a red flame. So remember your qualitative analysis book. Y is an ion that reacts with concentrated H2SO4 to produce H2S. So if you remember from the group 17 chapter, only iodide ions react with H2SO4 to produce H2S, which means it can either be barium iodide or strontium iodide. So we narrow it down to B and D because it's asking for the formula of compound containing X and Y, and we know that barium burns with an apple green flame and strontium burns with a red flame. So option D is the correct answer. Question 18. Oxides of nitrogen are present in the environment due to natural and man-made sources. Which row is correct? So natural source of nitrogen oxide is always lightning, so an electrical discharges in the atmosphere. Man-made source of nitrogen, you know, the internal combustion engine, and therefore A is the correct answer. Question 19. Magnesium hydroxide dissolves in aqueous ammonium chloride, but not in aqueous sodium chloride. Which statement explains this observation? The ionic radius of NH4 plus ion is similar to that of Mg2 plus, but not that of Na+. Now, ionic radius does not really affect solubility. So this cannot be the correct answer. We don't know if it's factually correct or incorrect, but the point is it's not related to dissolving at all. And then NH4Cl dissociates less fully than NaCl. Now again, the dissociation of NH4Cl and NaCl is not the point because these are not the ones being dissolved. What is being dissolved is magnesium hydroxide. So we don't really care about how much either of NH4Cl or NaCl dissociate. The Na plus and Mg2 plus ions have the same number of electrons. Again, how does this affect solubility? This does not affect solubility. Option D, the NH4 ion can donate a proton. Now this is correct because when NH4Cl, when you add it to magnesium hydroxide, it can donate. Magnesium hydroxide is a base, and remember the Bronsted-Lowry definition of acids and bases. A base is a proton acceptor. So magnesium hydroxide will like to accept protons, and the NH4 plus ion from ammonium chloride will have a proton to donate, but sodium chloride will not have a proton to donate, and therefore the ammonium chloride will donate a proton to magnesium hydroxide. A reaction will take place, which is why the solubility happens. So D is the correct answer. Question 20. The formula of a hydrocortisone acetate is shown. So they've given this. Which row is correct? We want to know the number of carbon atoms in one molecule and the number of chiral atoms in one molecule. So let's start with the number of carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, sorry, that's 9 already, 19, 20, 21, 22, and that's probably it. So it's, wait, I think I'm missing one over here. Yeah, 23, this methyl group. So be careful. There are 23 carbon atoms. Make sure you account for all of them. So we have narrowed it down to C and D. And then we have to see the number of chiral atoms in one molecule. So I'll use a different color for that. A chiral carbon atom is one that is bound to 4 different groups. So this is chiral, this is chiral, this is chiral, this is chiral, and then this is chiral, this is chiral as well, this is chiral as well. So in total we have 1, 2, 3, 4, 5, 6 and 7 chiral carbon atoms, and option C is therefore the correct answer. Question 21. Bromomethane CH3Br decomposes in the stratosphere forming methyl free radicals and bromine free radicals. Which row correctly describes this decomposition? Type of bond fission, remember it's forming free radicals, so it has to be homolytic. If it's heterolytic, it forms ions. If it's homolytic, it forms free radicals, so it has to be either A or C. And number of electrons in a bromine free radical will be the number of electrons in an atom of bromine, because an atom of bromine is essentially a free radical of bromine because it has one unpaired electron. So option A is the correct answer because it's 35. Now, question 22. Structural and stereoisomerism should be taken into account when answering this question. Y is a gaseous hydrocarbon which decolorizes aqueous bromine. And let's stop here. That means it's an alkene. It contains carbon-carbon double bonds. And it contains no rings. So we know that it's a straight chain, or branch chain, whatever. It's a straight chain or branch chain alkene. And 10 grams of Y occupies a volume of 3.43 dm cube under room conditions. Right. So we know that under room conditions, 1 mole of every gas occupies 24 dm cube. So if it's occupying 3.43 dm cube, we can calculate the number of moles. So 3.43 over 24 is equal to 0.142916667 moles. And we know that the formula of the alkene will be CxH2x, right? And we also know that N is equal to M over Mr. We know M, which means, and we also know N. So this means that we can calculate Mr because Mr is equal to M over N, so equal to 10 over 0.143, and this is equal to 70 grams per mole. And this means that 12x plus 2x, because CxH2x is the formula, is equal to 70, which means 14x is equal to 70, and therefore x is equal to 5, which means the alkene is C5H10. Now comes the next part of the question. This is a little mean because this is a very lengthy question. We have to calculate the structural and stereoisomers, how many possible there are, for this C5H10 alkene. So let's start drawing all of them out. It's better if you do this on a blank page. So CH3, CH2, CH2, CH, CH2, this is one. And then the second one is CH3, CH2, CH, CH, CH3. Now this will be into 2 times because cis and trans isomers. The first one will not have geometric isomers because this carbon atom is attached to 2 identical groups. And then the third one we have CH3, CH2, C, CH3, CH2, and this one will not have cis trans isomers again because of this carbon atom. Then 4, CH3, C, CH, CH3. So it's a gift really that there are no CH3 whole twice here. It's a gift really that there are no rings, because otherwise we would have to consider all the cyclic isomers as well. So you don't have to consider the cyclic ones because it says it contains no rings. So this one is next. So this will also not have any cis trans isomers because of this carbon atom attached to two identical groups, I mean. And then the last one is CH3 whole twice, CH, CH, CH2. And this one will also not have any cis trans isomers. So in total you have 1, you have 2 times 2, which is total 3, then 4, 5 and 6, and then therefore you have 6 possible isomeric structures, structural and geometrical. Question 23. Which equation represents a valid propagation step in the chlorination of ethane? So let's look at first one, C2H5Cl plus a chlorine free radical gives C2H4Cl plus HCl. This looks like a plausible answer, but let's see the other ones. C2H6 plus a chlorine free radical gives C2H5Cl plus an H free radical. Now this does not happen in propagation, so this is wrong. C2H5Cl plus a hydrogen free radical gives C2H5 plus HCl. This is an inhibition step, not a propagation step, because an inhibition step is basically when the compound is going back to what it was initially. So C2H5Cl receiving an H free radical to kick out the chlorine free radical. So this is just inhibiting the process of chlorinating the ethane. And the last one, C2H5 plus Cl gives C2H5Cl. This is termination because 2 free radicals combining to give one product. So the correct answer is A. Butanoic acid can be made from 1 bromopropane in 2 stages. So first there is a nucleophilic substitution where this bromine is replaced by this Cn, and then stage 2, the Cn is hydrolyzed to the carboxylic acid. So the first one is nucleophilic substitution. The question asks for which types of reactions are occurring in stage 1 and stage 2. So first one is nucleophilic substitution, second one is hydrolysis. And therefore the correct answer is C. Question 25. A halogenoalkane has the molecular formula C5H11Br. The halogenoalkane does not form an alkane when treated with ethanolic sodium, not form an alkene, when treated with ethanolic sodium hydroxide. So what could be the halogenoalkane? Which means that there is no elimination taking place, and therefore it has to be a halogenoalkane that cannot remove the bromine. And let's see which case that would be. So option A is CH3, CH2, CH, CH3 and CH2Br. So this is first one, 1 bromo 2 methyl butane, and this can have elimination to give the alkene, this one. So this is possible here, and therefore an alkene is forming, so this cannot be the correct answer. Option B, 2 bromo 2 methyl butane, and that will be 2 bromo 2 methyl butane. I'll draw it further out so that it doesn't clash, and that's CH3, CH2, C, CH3 whole twice and Br. So this is one option. 2 bromo, I'll number the carbon atoms. So 2-bromo, 2-methylbutane. And this can also have elimination to give the alkene, this one. So this can give this alkene, and therefore this is not possible. And then option C, 3-bromopentane. 3-bromopentane would be 1, 2, 3, 4, 5. This is 3-bromopentane. It can also give elimination products like this one. So this is also not correct, which means option D has to be the answer. Let's see why. So option D is 1-bromo, 2,2-dimethylpropane, and that is now this cannot give elimination products, because in order to eliminate, you'll remove the bromine from this carbon and you will have to remove a hydrogen from this carbon. But as you can see, there is no hydrogen attached to that carbon because there are 3 methyl groups attached to this carbon. So therefore, this is the correct answer, because you cannot have elimination because you have no hydrogen to remove while kicking out the bromine. So question 26 now. Compound P is heated under reflux with an excess of acidified potassium dichromate. I think we missed one question. Did we? No, we didn't. Okay. So question 26, compound P is heated under reflux with an excess of acidified potassium dichromate to form compound Q. Compound Q has a lower boiling point than compound P. Okay. So this is an oxidation reaction, remember, heated under reflux in an excess of aqueous potassium dichromate to form compound Q. So compound P can either be an aldehyde or an alcohol, ald or alcohol, because these are the only things that will get oxidized, right? So and compound Q will either be, and it's heated under reflux, so compound Q has to be a carboxylic acid. Compound Q has a lower boiling point than compound P. Okay, so let's see what we have. 2-methylbutanol will be CH3, CH2, CH, CH3, CH2OH. This is 2-methylbutanol. 1, 2, 3, 4, 5. And then when it gets oxidized, we get when it's oxidized under reflux, we get CH3, CH2, methyl group here, and a carboxylic acid group here. So that's P, that's Q in this case. For the second one, I'll move this to this side. For the second one, we have 2-methylbutan2ol, which is CH3, CH2, COH, CH3 whole twice. So this is 1, 2, 3, 4, 5, 2-methylbutan2ol, and you can see this is a tertiary alcohol, so it cannot be oxidized, so this cannot be the correct answer. And then the next one is pentanol, so that's CH3, CH2, 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 OH. So again, I'll draw this out neatly a little further out to avoid any confusions. This is pentanol. It can be oxidized to a carboxylic acid. So this is the carboxylic acid that it's being oxidized to. And the last one is pentanol, which is, and this oxidizes to a ketone. Now, for option A, C, and D, we have A and C going to carboxylic acid, and we have D going to ketone. And it says that compound Q has a lower boiling point than compound P, which means the answer has to be D, because a carboxylic acid can form very strong attractions due to hydrogen bonds, and therefore will have a higher boiling point than compound P, because it not only forms hydrogen bonds like compound P, but it also forms these permanent dipole-dipole interactions from the carbonyl group. Whereas in the ketone, there are no hydrogen bonds and there are only permanent dipole-dipole attractions. So you're going from hydrogen bonds in the alcohol to permanent dipole-dipole attractions in the interactions in the carbonyl in the ketone. So the boiling point of the ketone will be lower. And I'm sorry, I forgot that here I wrote only carboxylic acid can be the product, but you can also have ketone. Because if it's a secondary alcohol, it will be a ketone. If it's a primary alcohol, it will be a carboxylic acid. Question 27. Structural and stereoisomerism should be taken into account when answering this question. An organic compound X is dehydrated by heating with concentrated phosphoric acid. Okay, so we are going from an alcohol to an alkene. That means only two organic products are formed. What could be X? So if you look at option A, what we get is this alkene, and this will be into 2 because cis and trans. And then the next one, when we dehydrate this, we can either have this alkene, or we can, we'll also have another alkene, which is this one, and this will be into 2 cis trans. So that's a total of 3 alkenes, which is not good because we only want 2 organic products, not 3 of them. And option C, there'll be option C, we have this one, and this will be into 2 because cis and trans, and we'll also have this one. So we have 3 again for this one. So 3, 3, B and C, therefore not possible. Option D, we can have, oh god, lots of different combinations, because you can dehydrate this, you'll have this one and this one, you can dehydrate this, you'll have this one and that one. So too many options. D cannot be the answer. A is the only one which is giving 2 organic products. Question 28. Which compound produces a precipitate with 2,4-DNPH reagent and also with alkaline aqueous iodine? So 2,4-DNPH means it has to be a carbonyl compound, which means aldehyde or ketone. And therefore, if we read the options, we have already eliminated A. And then, because it's not going to react with 2,4-DNPH. And it also reacts with alkaline aqueous iodine, so it has to be a CH3CO group, which is, let's see if it's present in any of these. Butanol is CH3, CH2, CH2, CHO, so CH3CO is not present. Butanone is CH3CO, CH2, CH3, so this is a feasible one. And then CH3, CH2, CO, CH2, CH3. Again, this cannot be done because it does not have CH3CO group. It will not react with alkaline aqueous iodine. So C is the correct answer. Question 29. Organic compound Z has an alcohol group and a carboxylic acid group. Compound Z reacts with magnesium carbonate to make a salt with a relative formula mass of 230.3. And compound Z does not react with acidified potassium manganate. Okay, so it says that compound Z reacts with, it has an alcohol group and a carboxylic acid group. It reacts with magnesium carbonate to make a salt with the relative formula mass of 250.3. Now only the acid group will react with magnesium carbonate. The alcohol will not react with magnesium carbonate. So, okay, and then compound Z does not react with acidified potassium manganate. And it may also it makes a salt with the relative formula mass of 230.3. So this means there will be a salt form, which means MgR2 will be the formula. R is the basically organic chain, because there is one carboxylic acid group which will have the carbonate ion, this ion, and carboxylate ion, not carbonate, carboxylate ion, and we have Mg2 plus. So you need 2 units of this to balance the charge with Mg2 plus. So it will be an MgR2 salt, and the MgR2 salt should have a mass of 230.3. And compound Z does not react with acidified potassium manganate, because which means that the alcohol does not oxidize and the alcohol will only not oxidize if it's a tertiary alcohol, 3-degree alcohol. So we know it has a tertiary alcohol group, we know it has a carboxylic acid group, and we know that when the carboxylic acid reacts with magnesium carbonate, an MgR2 type salt is formed with a mass of 230.3. So with all of this information in hand, let's look at the options to identify Z. A is CH2-hydroxy-2-methylbutanoic acid, which is CH3CH2, CCH3 and OH and CO2H. So this is a tertiary alcohol, which means A is feasible. And let's do the rest of the stuff. Let's eliminate all the ones which are not tertiary alcohols, so that we don't have to calculate the formula mass of each and every one of them. And then B is 2-hydroxy-2-methylpropanoic acid, CH3 whole twice, C OH and CO2H. Again, this is a tertiary alcohol, so this is also correct. I mean it can be correct. 3-hydroxy-2-methylbutanoic acid will be CH3CHOH, CH3 CO2H. Now this is a secondary alcohol, so it will react with potassium manganate to form a ketone, so this cannot be the correct answer. And then the last one is 3-hydroxy-2-methylpropanoic acid, which is basically one carbon less, so CH2OH, CH3 and CO2H. So this is a secondary alcohol again, and sorry, not a secondary alcohol. I made a mistake there. It should be a primary alcohol because it's CH2OH. Yeah, this is the thing. So this is the primary alcohol right here. It will oxidize to give an aldehyde or a carboxylic acid. So it will react with potassium manganate. So this cannot be the answer, and therefore it should be either of A and B. So let's focus on those. So when A reacts with MgCO3, we get this salt. We get this. So we get twice of that and 2 of this. So I'll actually write it as this, not without the charge. And if we calculate the total mass of this, it will be 258.3. Just use the values of the ARs in the periodic table and calculate the total mass. 258.3, which is not what we want, so A cannot be the answer, which means B is the answer. But we'll cross check again. We'll calculate the mass for the salt of B, and the salt of B would be CH3. This is the same thing but without the OH and only the O, and twice Mg. The mass, it does come out to be 230.3 if you add up everything. So B is the correct answer. Question 30. The infrared spectrum of Y is shown. Now just don't read the question now, only interpret the spectrum. Have everything in hand, then do the question. So you look at the spectrum, interpret it regardless of what the question asks. And this will be OH, CH, CC, and this will be CO, single bond. So we have CO single bond, we have OH, so alcohol group present, and no carbonyl, no CO, because we can't see any peak for CO, and we have an alkene present. So we can rule out this because this is an ester. A is an ester, and therefore it cannot be the answer. We can rule out C because it's a carboxylic acid. Again, it has a CO double bond. We cannot have it. We have that. We can rule out D as well because CO double bond. Again, and we can't have that because not there in the spectrum. So B is the answer, and it should be the answer because it has an OH group and it has a carbon-carbon double bond. So now we move on to section B, question 31. The Boltzmann distribution diagram shows a fixed amount of a gas at two different temperatures, T1 and T2, right? Which statements correctly describe the features of this diagram? Temperature T1 is lower than temperature T2. Yes, that's correct, because as you increase the temperature, the curve flattens and moves towards the right. So T2 has to be greater than T1. And then the shaded area indicates the particles that have sufficient energy to react at T2. That's correct as well, because this whole shaded area, it is for particles with sufficient energy to react and at T2. And the total area under each curve is the same for both temperatures. Yes, because the total number of molecules is the same, so the total area under each curve will also remain the same. So I meant to place a tick over here, so it's A. All three are correct. Next question, 32. 4 solutions, each of concentration 0.1 mole per dm cube, were tested with a pH meter. The results are shown. So acid 1 gave a pH of 4 at 0.1 mole per dm cube. Acid 2 gave a pH of 1. Base 1 gave a pH of 11. Base 2 gave a pH of 14. Which statements explain these results? Acid 2 has a lower pH than acid 1 because it is more soluble. That is wrong, because acidity does not depend on solubility, it depends on the dissociation of the ions. Base 2 has a higher concentration of hydroxide ions in solution than base 1. That is correct, because base 2 is more basic because it has a higher pH, which means it has a higher concentration of hydroxide ions. It dissociates more into hydroxide ions. Acid 1 dissociates less than acid 2. That's correct as well, because the lower the dissociation, the higher the pH of an acid. So that's correct, and therefore C is the answer. Which reactions are redox reactions? Mg plus 2HCl gives MgCl2 plus H2. This is a redox reaction because you have Mg in zero oxidation state here and you have Mg2 plus here. So definitely. And you have H plus here and H in zero oxidation state here. So again, it's a redox reaction. K2CrO4. So 2 potassiums total will give +2, +1 for each. 4 oxygens total will give -8, -2 for each. So overall this compound is neutral, which means the chromium should be +6. And then on the right side, -14 from the oxygens, +2 from the potassiums, and therefore +12 for the chromiums, but there are 2 of them, so +6 for each. So this cannot be redox because the oxidation state of chromium remains the same. And if you look, the oxidation state of potassium also remains the same. For each potassium it was +1 here and it's +1 here as well. So for everything the oxidation state remains the same, not a redox reaction. Copper carbonate plus 2HCl gives copper chloride plus H2O plus CO2. Again, this is not a redox reaction because copper is 2 plus here, because carbonate is -2 and copper is 2 plus, and in copper chloride also copper is 2 plus because each chlorine will be -1, so total -2, overall neutral. And as you can see, it's not a redox reaction. So the answer for this one is D. Oh, sorry about that. Question 34. When the liquid N2F4 is heated, it decomposes into a single product X. Which statements are correct? Okay. NF bonds are broken during this decomposition. That's wrong, because if you look at what's happening, NF, this is N2F4 and it gives NF2. So each nitrogen is still bound to 2 fluorines. So NF bonds are not breaking during this decomposition. The enthalpy change when N2F4 decomposes into X is approximately plus 160 kilojoules per mole. Now, if you use your data book where they've given you the bond energies, you'll know this is correct. Molecules of X are non-linear, and that is correct as well, because the single product F, N2F4, will be something like this because the nitrogen will have lone pairs. So they have to be non-linear. So the answer is C for this question. Question 35. The following statements compare some properties of the oxides and chlorides of sodium and silicon. Which statements are correct? The melting point of silicon chloride is higher than the melting point of SiO2. This is wrong because silicon chloride is simple molecular silicon dioxide is giant covalent structure. Remember, it is similar to the diamond structure. So the melting point of SiO2 will definitely be higher. SiCl4 reacts with water, NaCl does not. This is correct because SiCl4 reacts with water to give SiO2 and HCl gas, whereas NaCl dissolves in water. It does not react with water. The melting point of SiCl4 is lower than the melting point of NaCl. This is correct because SiCl4, as I said, is simple covalent, simple molecular, with van der Waals forces between molecules. NaCl is giant ionic, so definitely NaCl will have a higher melting point. So C is the correct answer. Next one is question 36. Which statements about ammonium chloride are correct? It reacts with hot aqueous sodium hydroxide to produce an alkaline gas. This is correct because remember, whenever ammonium salts react with the base, ammonia is produced and ammonia is alkaline. So this is correct. In solution, it reacts with aqueous silver nitrate to produce a white precipitate. And this is correct as well because when you add ammonium chloride to silver nitrate, silver chloride is formed and AgCl, remember, is white precipitate. When solid, it reacts with concentrated sulfuric acid to produce chlorine. It will not react with sulfuric acid because sulfuric acid is an acid and ammonium chloride is also acidic because remember, it reacts with a base. So it has to be acidic and two acids will not react with each other. So B is the correct answer. Question 37. What is the same for a pair of optical isomers? Their empirical formula? Yes. Their functional groups? Yes. Their structural formula? Yes. Because optical isomers are stereoisomers, they have the same structural formula, same molecular formula, same empirical formula, only with different arrangements of atoms in space. So A is the correct answer for this one. Okay, the question 38. Which of the molecular formulae represent at least one compound that can undergo addition polymerization? C4H8 is an alkene. So in some isomers, yes, it's an alkene, so it will polymerize to give, it will undergo addition polymerization. C2H3Cl is basically CH2CHCl, also an alkene, so it will undergo addition polymerization. And C3H6O, you can have various formulas for this, but for example, you can have CH3COCH3. This will not undergo addition polymerization, but you can also have CH3CHCHOH, which will undergo addition polymerization. So it says at least one compound. Each formula, it can represent lots of different compounds. For example, C4H8 can be an alkene, it can be a cyclic alkane, but it can be many things. But the point is that it represents at least one compound that can undergo addition polymerization. So all three do, and therefore A is the correct answer. The penultimate question: which of the reactions give products containing a chiral center? CH2OH COCO2H plus excess of HCN. This is a nucleophilic addition reaction. So this will be HOCH2C OH CN CO2H, and this is a chiral center, as you can see, because it's attached to 4 different groups. So the correct answer will be this will be a part of the answer. And then CH2OH CO2H and an excess of NaBH4. NaBH4 is a reducing agent. It reduces carbonyl compounds, but it does not reduce carboxylic acids. So it can reduce this group, but it will not reduce this group. So this will give CH2OH CHOH because the ketone is reduced to a secondary alcohol, CO2H. And again, this has a chiral center right here. So this is also part of the correct answer. And the last option, CH2OH COCO2H plus an excess of LiAlH4. Now lithium aluminium hydride is also a reducing agent, but it can reduce carboxylic acids and carbonyl compounds. It's a stronger reducing agent than NaBH4. So you get HO CH2 CHOH CH2OH. So this is not a chiral center because you have 2 identical groups attached to it, and therefore this is not a part of the answer, so the answer is B. The last question, ethyl butanoate is heated with the dilute aqueous solution of sodium hydroxide. Which substances are products of this reaction? So this is an ester, ethyl butanoate. Let's draw it out. CH3, CH2, O, CO, CH2, CH2, CH3. This is the ethyl part and this is the butanoate part. So ethyl butanoate, and it reacts with an alkali, sodium hydroxide. So remember, alkaline hydrolysis of esters gives you the alcohol plus the sodium salt of the carboxylic acid. The salt of, not because if it's acid hydrolysis, it will give you the carboxylic acid. If it's an alkaline hydrolysis, it will give you a salt of the carboxylic acid. So this will give you CH3, CH2, CH2, COO, Na, which is sodium butanoate. So which substances are products of this reaction? Sodium butanoate, yes. Water, no, we can't see any water here. Sodium ethanoate, no. Why would that form? So D is the correct answer. So that was the October-November 2021 paper 12. I hope the answers helped and the explanations helped. And if you have any problem, as always, leave them in the comment section. I'll try my best to answer them. So see you next time. Thank you.